Have you ever, thought about this? Is there, a problem, so hard that even a computer, even like the best computer ever, could never, ever solve it?
Hmm. That's a really interesting question. It really makes you think about what computers really are, what
Yeah.
they can and can't do, you know?
Yeah, that's where this whole halting problem comes in, right?
Exactly, yeah.
We've got like a ton of stuff on this, a video and a study guide, FAQs, even a briefing, and a timeline. But for those of us who aren't, computer science whizzes, what is this halting problem thing, and why should we even care?
Okay, so imagine you have a program, any program, right? It could be, I don't know, like a simple calculator app or something super complex like an AI simulation,
Hmm.
and you give it some input, and then you wait to see what happens. Sometimes it just finishes, it gives you the answer, but sometimes it gets stuck. It
Wow.
might crash or freeze, or maybe it just keeps running forever, like in an endless loop.
Ugh, the spinning wheel of death. We've all been there.
Exactly, exactly. So the halting problem, it asks this like really basic question.
Hmm.
Can we make a program, let's call it, I don't know, the halting oracle, that can look at any program and its input and just tell us, will this thing ever stop or is it going to run forever?
Okay, so it's like a universal bug checker,
Yeah.
or like a crystal ball for your software. That would be super useful. Like no more crashing, no more freezing.
Right, you got it.
Yeah.
But here's the crazy part.
Okay.
Alan Turing, who basically invented computer science, he proved way back in 1936 that this halting oracle, this program, it can exist.
Wait, hold on. Are you saying there are problems that no computer, no matter how amazing it is, could ever solve? Really?
Yeah, yeah. The halting problem, it shows us that there are limits to what computers can actually do. Some problems, no matter how smart the algorithm, no matter how powerful the computer, they're just undecidable.
Wow. Okay, I'm definitely intrigued, but also a bit confused. How did Turing even figure this out? What's the logic behind it?
So to understand Turing's proof, we kind of have to get this idea of a Turing machine.
Okay.
It's not a real machine. It's more like a theoretical model of computation.
Oh, okay. So not something I can just buy on Amazon.
Right, right. Picture it like a really basic device. It has a tape, a head that can read and write symbols on the tape, and a set of rules that tell the head what to do based on what it reads.
Okay, I'm kind of picturing a really, really old typewriter hooked up to a roll of toilet paper.
You're not far off, actually. The amazing thing about the Turing machine is that even though it's super simple, it can basically do any computation that a real computer can do. And that's why it's so important for understanding the halting problem.
So it's like this theoretical machine. It helps us understand what's possible and impossible for any computer, right? Even the ones we haven't even invented yet.
Exactly, exactly.
Yeah.
So Turing's proof, it's like a logic puzzle. He uses this technique called proof by contradiction.
Proof by contradiction. I think I remember that from high school geometry, maybe. But can you remind me what that is?
Sure. Basically, you start by assuming the opposite of what you're trying to prove. So in this case, we assume that a program that solves the halting problem, it does exist.
Hmm.
And then you show that this assumption leads to something impossible, a paradox. And if your assumption leads to a paradox, well, it has to be wrong.
So it's like saying, if I could be in two places at once, then I'd be both here and not here, which is impossible. So I can't be in two places at once.
Yeah, that's a great way to put it.
Okay.
So Turing, he used this really clever trick to create this paradox. He came up with this idea of what he called a devil's advocate program.
Okay, devil's advocate.
Yeah,
First.
imagine a program that's designed to do the exact opposite of what our halting problem solver predicts.
Oh, okay. Sneaky. So if the halting problem solver says this program will eventually halt, the devil's advocate program just keeps running forever.
Yeah, exactly.
But what if the halting problem solver predicts that the devil's advocate program will loop forever?
Then the devil's advocate does the opposite. It just immediately halts.
Ah, so it's like this digital rebel always doing the opposite of what it's told?
Exactly. And this paradox, this contradiction, that's the core of Turing's proof.
Okay, I think I'm starting to get it. But it all depends on this whole Turing machine idea, right? How can we be sure that this simple model covers every possible type of computation? What if there's some other way to compute that we just haven't thought of yet?
That's a great question, and it gets to the heart of why the halting problem is so important. Turing machines they're basic, sure, but they're also incredibly powerful. Anything a real computer can do, basic math, complex simulations, anything can be simulated on a Turing machine.
So it's not about the limits of our current technology. It's really about the fundamental nature of computation itself.
Exactly.
Wow. Okay, my mind is officially blown. So if there are problems that computers just can't solve, even in theory, what does that mean for us? Like, practically speaking, what are the consequences? Does it mean there are things that AI can never do either?
Those are great questions, and they're exactly what we'll be digging into in the next part of our deep dive.
Okay, wow. I'm still trying to wrap my head around the fact that there are problems that even the most powerful computer could never solve.
Yeah.
It's kind of like, finding out that there are places that Google Maps just can't get you to.
It's definitely humbling, isn't it? But the halting problem, it's not just like a dead end. It's more like, a detour sign pointing us in a new direction.
Oh, interesting. So instead of trying to find this magical algorithm that can solve everything, we need to be a bit more, I don't know, strategic, more focused.
Exactly. Think about it this way. You wouldn't use a hammer to fix a leaky faucet, right?
Yeah.
Or a screwdriver to bake a cake.
Right. Different tools for different jobs.
Exactly. The halting problem tells us that the same idea applies to, computation.
So instead of trying to build like one super AI that can do it all, we should be focusing on developing specialized AI systems that are really good at specific things, like an AI that's amazing at, diagnosing diseases, but maybe not so great at writing poetry.
Exactly. And we're already seeing this happening in AI research. Instead of chasing this, this dream of general intelligence, researchers are focusing on developing AI systems for very specific tasks like image recognition, natural language processing, even playing games, predicting the stock market, you name it.
That makes sense. But doesn't this mean that there will always be limits to what AI can do? If we can't create this universal AI that can solve any problem, does that mean that like true artificial general intelligence, the kind we see in sci-fi movies, is that just a fantasy?
Well, that's a really big question, and there's no easy answer. The halting problem, it really highlights the limitations of just using algorithms to try to create intelligence. It kind of suggests that some things about human intelligence, like creativity, intuition, even consciousness, those things might be really hard or maybe even impossible to replicate in a computer.
So even as AI gets more and more advanced, there might be some parts of human thinking that it just can't do. Like
Yeah.
a computer might be able to beat a grandmaster at chess, but it might never really understand the beauty or the strategy of the game, the way a human can.
That's a good way to put it. The halting problem makes us really think about what intelligence really is and whether to be fully explained just by algorithms and computation. It's like, is there more to intelligence than just processing information and following rules?
Okay, now we're getting into some pretty deep philosophical stuff here.
Yeah.
But it's really interesting. So practically speaking, how does this shift towards specialized AI, how does that play out in the real world? What kind of like advancements can we expect to see? And are there any downsides we should be thinking about?
Well, on the positive side, we're already seeing incredible progress in fields like machine learning, especially deep learning. These systems, they learn from huge amounts of data, and then they can make predictions or decisions based on what they've learned.
Right, like all those breakthroughs we hear about all the time, self-driving cars, personalized medicine, even AI that can create art or music. It seems like AI is already having a huge impact.
Absolutely. And while these systems are still pretty new, they're already doing some really amazing things. The key is they're not trying to solve the halting problem. They're focused on very specific tasks, and they're getting better and better at those tasks all the time.
So it's like, instead of trying to create one AI master chef that can cook anything, we're focusing on creating AI sous chefs that are each experts in their own little area.
Perfect analogy. And this specialization is allowing AI to make incredible progress in all sorts of fields. Healthcare, finance, transportation, you name it.
That's exciting. But what about the potential downsides? Are there any risks we should be thinking about as we start to rely on specialized AI more and more?
Oh, absolutely. There are definitely some ethical and societal issues that we have to consider very carefully. For instance, as these AI systems get more and more sophisticated, we need to make sure that they're used responsibly, that they don't just reinforce existing biases or create new inequalities.
Right, like if an AI system is trained on data that's already biased, it might make decisions that are discriminatory, even if it's not programmed to be that way.
Exactly. And as AI starts to take on more roles in areas like healthcare and criminal justice, we need to make absolutely sure that these systems are transparent, accountable, and aligned with our values as humans.
So it's not just about developing powerful AI, It's about developing AI that's ethical, fair, and beneficial for everyone.
Yes, it's a challenge, but it's a challenge we need to face head on. The halting problem, it reminds us that technology is a tool, and like any tool, it can be used for good or for bad. It's up to us to decide how we want to use this incredible technology and to make sure that it serves humanity's best interests.
That's a pretty sobering thought. But it's also empowering in a way. We're not just, passive passengers on this technological roller coaster. We actually have a responsibility to steer it in the right direction.
I totally agree. The halting problem might tell us that there are limits to what we can compute, but it doesn't limit our imagination, our creativity, or our ability to shape the future of AI in a positive way.
Okay, I'm feeling a mix of like possibility and caution right now. But I have one more question. You mentioned that the halting problem raises questions about consciousness, right? Is it possible that AI could ever become conscious even if it can't solve this unsolvable problem?
Ooh, that's a question that takes us deep into the realm of speculation. Some people believe that consciousness is something that just emerges from complex systems, and that a really sophisticated AI could theoretically become conscious. Others say that consciousness is something completely different, something that can't be recreated in a machine no matter how complex it is.
So is this just a philosophical debate, or is there any scientific evidence to support either side?
The thing is, we don't really fully understand consciousness yet, even in humans. We don't know exactly how it arises from, the physical matter of the brain. So it's really hard to say whether a machine made of, silicon and code could ever experience consciousness in the same way we do.
So it's like trying to solve a puzzle when we don't even know what the pieces are or what the final picture is supposed to look like.
Exactly. The halting problem gives us a new perspective on this debate. It suggests that even if we could create an AI that's smarter than humans in a lot of ways, there might still be limits to what it can understand and experience.
So even a super intelligent AI might still be limited by the fundamental nature of computation itself. It makes you wonder if there are like parts of the universe that are just beyond the reach of any computational system, no matter how advanced.
It's a possibility worth thinking about, and it brings us back to Alan Turing, the guy who first came up with the halting problem. He wasn't just a brilliant mathematician. He was also deeply interested in the philosophical side of things. He thought that understanding the limits of computation could help us understand the human mind better.
So the halting problem, it's not just a technical problem for computer scientists, it's also a philosophical puzzle for all of us.
Exactly. It makes us think about the connection between mind and machine, between knowledge and computation, between what we can know and what we can't know. It's a reminder that even in this increasingly digital world, there are still mysteries out there that algorithms just can't solve.
This deep dive has been amazing. We've talked about the limits of computation, the potential of AI. We even touched on consciousness. But before we wrap up, I'm curious about Alan Turing himself. From what we've seen on the timeline, it sounds like he was a really important figure, not just in computer science, but in history overall.
Oh, absolutely. Alan Turing was a true visionary, and his life, well, it was as extraordinary as his work, full of triumphs and tragedies. It's a story that deserves its own chapter.
Well, consider my curiosity piqued. I'm definitely ready for part three.
Let's
Okay,
do
so
that.
let's hear about Alan Turing. Like, who was this guy?
Well, Alan Turing, he was really a remarkable person, born back in 1912, and even as a kid, he was like amazing at math and logic. Went to Cambridge, and get this, he started laying the foundation for theoretical computer science even before electronic computers were even a thing.
So he was like thinking about computation in this totally abstract way. That's wild. It's like he was making up the rules for a game that nobody even knew how to play yet.
Yeah, it really is. His idea of the Turing machine, it was like a thought experiment, but it turned out to be incredibly important. It gave us a way to think about computation in a really general way, without being tied to any particular type of computer. Like, he discovered the basic laws of computing.
And this was all happening in the 1930s, right?
Yeah.
Like a pretty crazy time in the world.
Yeah, right in the middle of everything. And then World War II breaks out, and Turing's life takes this really dramatic turn. He gets recruited to work at Bletchley Park, this top secret code breaking center in Britain.
Wait, so the guy who came up with the halting problem was also like a code breaker. That's like something out of a movie.
I know, right? And Turing was like essential to the Allied victory. He helped design and build this machine called the bomb, and they used it to like crack the Enigma code that the Germans were using.
So his work on computation actually had this real world impact that like changed history.
Absolutely, yeah. They say that Turing's work at Bletchley Park might have shortened the war by years, saved countless lives, but
Yeah.
but his work was like top secret, so he couldn't even get credit for it during his lifetime.
It's incredible, right? This one guy, he was like cracking these super complex codes and thinking about the deep philosophical limits of computation. Like he was living in two totally different worlds at the same time.
He really was an amazing mind, but unfortunately his story, it doesn't have a happy ending. After the war, things took a really bad turn. Turing was prosecuted for being gay, which was illegal in Britain at the time.
Oh, that's awful. That someone who did so much for his country was treated like that just for being who he was.
It was a terrible injustice. He was forced to undergo chemical castration, and then in 1954, when he was only 41, he died from cyanide poisoning. Most people believe it was suicide.
That's just heartbreaking. It makes you wonder what else he could have accomplished if things had been different.
Yeah, it really is a tragedy. But the good news is that in recent years, people have started to recognize how important Turing was. He's considered a national hero in Britain now, and people are finally celebrating all that he did for computer science and for the world.
Well, that's good to hear, even if it, took way too long. So, like, what can we take away from Alan Turing's story? It seems like there's like a lot more to it than just the halting problem.
Oh, for sure. I think Turing's life teaches us some really important things. First, it shows us the power of abstract thinking. His work on the Turing machine, it shows how theoretical ideas can have these huge real-world consequences, even in ways you might not expect.
Right, like he was able to see things that other people couldn't because he was thinking about things in this really different way.
Exactly. And second, Turing's story reminds us how important diversity and inclusion are in science and in society as a whole. What happened to him, it shows us how much we lose when we let prejudice and discrimination get in the way of people's talent.
It's true. We need to create a world where everyone can be themselves and contribute in their own way.
Absolutely. And finally, I think Turing's life, it's just inspiring. He shows us that we should always follow our passions, challenge the way things are, and try to make the world a better place, even when things are tough.
That's a great way to put it. This deep dive has been, well, it's been a journey. We've talked about some really complex stuff, but it's been really fascinating, and I think it's ultimately a hopeful story.
I agree.
It shows us that even though there are limits to what we can know and what we can do with computers, the human spirit that has no limits.
Yeah, beautifully said. And if anyone out there wants to learn more about Alan Turing, I really recommend the book Alan Turing, The Enigma. It's a really great read.
I'll have to check that out. And to all our listeners, thanks for joining us on this deep dive. We'll be back next week with another one. Until then, keep those brains buzzing.